Today we're going to learn about Chapter 1, Section 2, Analyzing Graphs of Functions and Relations. Here is the new vocabulary for the section. Please copy them down and find their definitions. Pause the video at this time. Okay, we're talking about advertising where the function is f of x equals negative 5x squared plus 50x. Approximates the profit a toy company where x represents the marketing costs and f of x represents the profit. Both costs and profits are measured in tens of thousands of dollars. Use the graph to estimate the profit when marketing costs are $30,000. Confirm your estimate algebraically. So we come to our graph and 30,000 is going to be where the 3 is. So we're going to go straight up 3 right here and find that it is going to be approximately 105,000. So graphically we're looking at 105,000. Now we want to check this algebraically. Well, to do that we have to plug in the function, and we're going to plug in for x, we're going to plug in 3. So we're finding f of 3 because it's 30,000 and that's it. The graph is in tens of thousands, so it's 3 times 10,000 gives me 30,000. So that's equal to negative 5 times my 3 squared plus 50 times 3. Okay, that gives me f of 3 is equal to negative 5 times 9 plus 150. So f of 3 equals negative 45 plus 150, which gives me f of 3 being 105. We change that into tens of thousands, and the profit is 105,000. And that's how we do it algebraically. Now in this example, we're looking at the same data, but this time we're going to find out if I want to have $1,250,000 in profit, how much are my marketing costs going to be? Well, instead of plugging in for x this time, f of x is the 1,250,000. Well, we change that into terms of 10,000s because that's what we're measuring by, and that's 125. So to do it algebraically, our f of x is 125. Now just looking at it graphically, I'm going to go to 125,000, which is about right here, and I'm going to say that my marketing cost is going to be 5, or 5 times 10,000, $50,000. That's my estimate by looking at the graph. Now if I'm doing the algebra, I'm going to go ahead and do 125 is equal to negative 5x squared plus 50x. Okay. Now I get all that, set it equal to 0, and I get negative 5x squared plus 50x minus 125 equals 0. Because I'm solving a quadratic, and to solve a quadratic I have to set it equal to 0. So to solve a quadratic I have to factor. So I'm going to factor out a negative 5, which gives me x squared minus 10x plus 25 equal to 0. Well, I know that factors as x minus 5 squared equals 0. So that means my x my x equals 5. So I translate that, and that means the marketing cost is going to be $50,000. Okay. Next, we're going to use the graph to find the domain and range of the function. Well, the domain are the x values. So if I go and I follow along the x-axis and look for the function as I'm going along the x-axis, I can see where the function exists. Over here on this side, I see that my function will continue on going that direction. On the right-hand side, I see that my function stops right here. So my domain is going to be the domain starts at negative infinity and stops right here at 1, 2, 3. And it includes 3, so that's going to be a bracket. So my domain is negative infinity to 3. Now I'm going to look at the range. Well, the range is following up and down on the y-axis. So I'm going to follow my function up and down on this y-axis. If I start down here at the negative, I notice that my function is continually on in the negative direction, which means it's going to negative infinity. But as I go up on the y-axis, as I go this way, I notice that I have a stopping point in my graph right here. Okay, so that tells me everything I need to know about my range. My range starts way down here, down there at negative infinity, and it goes up to this point right here, which is 2 above the axis, or my y value is 2. And it goes up to and includes 2, so that means it's going to be a bracket. So my range for this function is from negative infinity to positive 2. Okay, we're going to find the y-intercepts of a function graphically, and then we're going to find the intercepts algebraically. Well, the y-intercept is all we're looking for, and that's where it crosses the y-axis. If we look, we see that it crosses the y-axis right here. Well, that's 1, 2, 3, 4 up on the y-axis, so that's the point 0, 4. That is my y-intercept if I'm looking at it graphically. If I don't have a graph and all I have is the function f of x, that means I'm going to find f of 0. And f of 0 equals to 0 squared minus 4 times 0 plus 4. Well, that's going to give me f of 0 equals 4, which means, again, the point is 0, 4. So we found it either graphically, if I have a graph, or I can do it algebraically. Okay, I'm going to find the y-intercept of my absolute value function, and I see graphically all I have to do is look where it crosses the y-axis, which is right here, which is then the point 0, negative 1. Now again, algebraically, I'm going to look for g of 0, because it's when x is 0, is equal to the absolute value of 0 plus 2 minus 3. Okay, the absolute value of 0 plus 2 is 2 minus 3, so g of 0 equals negative 1, which gives me the point of intersection of 0, negative 1. So now we're able to do the y-intercepts again graphically or algebraically. Okay, now we're going to find zeros, or where our graph crosses the x-axis? Well, we can again do it graphically if we have a graph and we see we have a point here, a point here, and a point here. So graphically, I have the points -1, 0. I have the point 0, 0. And I have the point 1, 0. Okay? I have, in this case, I have 3 zeros. The most of the y-intercepts I can have and have a function is 1. The number of zeros depends on your function. Okay, now we find it algebraically. Well, if we look at all of our points that we had previously, it's the y that is 0 this time. So we set our equation, f of x is going to be 0, so that's 0 equals x cubed minus x. Okay, it's set up to be solved, so we have to factor to solve. So we factor, and that gives me x as a common factor, and that gives me x squared minus 1 equals 0. I know I can factor x squared minus 1, so my factors now become x, x plus 1, x minus 1, and they're all equal to 0. So x equals 0, that's that answer. When I solve this, that's going to give me -1, and this one gives me +1. So that means I have the points 0, 0, -1, 0, and 1, 0, which I see are the same answers I got when I did it graphically. Now, pause the video so you can copy this down. These are what we need to be able to test for symmetry. Okay, looking at the graph, we should be able to notice that we have a symmetry around the y-axis. Well, to check that out, we know that from our previous page that the points x, y must match up with the points -x, y. And let's look at a couple of ordered pairs. I've got the ordered pair 1, 3. I have the ordered pair that matches with it, -1, 3. I also have 2, 6, which matches with -2, 6. Okay. Now, we can also check for y-axis symmetry by doing f of x and f of -x. f of x has to be equal to f of -x. So my f of x is x squared plus 2, and my f of -x is -x squared plus 2. Okay, when I simplify the right-hand side, I get x squared plus 2. Since f of x is equal to f of -x, then we have symmetry with respect to the y-axis. Okay, looking at it graphically, it looks like we have symmetry with respect to the origin. So let's check it out. For symmetry with the origin, our ordered pairs should look like this. X, y should go with a -x and a -y. So let's check a couple of points. We've got -3, 2, and we get it pairs up with 3, -2. We've got the point -2, 3, and it pairs up with the point 2, -3. Noticing that the second ordered pair, both the x and y are opposites. Okay, we need to check it out. So we're going to do algebraically xy is equal to negative 6. That means that it has to be this part of on the right hand side, negative x negative y equals negative 6 must look the same as the left hand side. Well, a negative times a negative is going to give me a positive, so that's xy equals negative 6. And they are exactly the same, so we have symmetry with respect to the origin. Okay, you'll need to pause the video and copy these down. These are the concepts for even and odd functions. An even function is when we have symmetry with the y-axis. An odd function is when we have symmetry with respect to the origin. Okay, we've already graphed the function for you from a graphing calculator, and we're looking at the graph and analyzing it. We don't see any symmetry, but we can check. So we have our original function, f of x equals x squared minus 4x plus 4. Okay. One of the things we need to check for is when x is negative, and that gives me negative x squared minus 4 times negative x plus 4. Okay, that gives me x squared plus 4x plus 4. F of x is not equal to f of negative x. Therefore, that function is not an even function. Now we got one more to check. We already know what f of negative x is. We need to check negative f of x. Well, that means all I need to do is change all the signs of my function. Positive x squared becomes negative x squared. Minus 4x becomes plus 4x. And plus 4 becomes minus 4. Well, if we check negative f of x and f of negative x, they are not equal. F of negative x is not equal to negative f of x. Therefore, our function is not an odd function either. So this one is neither. Okay, we went ahead and graphed the function, and we're going to analyze it. By looking at it, it looks like it is symmetric about the y-axis. Well, let's go ahead and check it. To do that, all I have to do is use our f of x that we're given. F of x equals x squared minus 4, and compare it to f of negative x. Well, when I put negative x in there, I get x squared minus 4, which is exactly what f of x is. So f of x is equal to f of negative x. Therefore, we have an even function. Okay, we have one last one that we want to check for even and odd. As I'm looking at it, since the graph does not go through the origin, I am going to make the assumption that it is not symmetrical. Well, again, if I check through all my functions, first starting with f of x is equal to x cubed minus 3x squared minus x plus 3. Okay, there's my f of x. Then I need to do f of negative x. And that gives me negative x cubed minus 3 times negative x squared minus a negative x plus 3. Well, that gives me negative x cubed minus 3x squared plus x plus 3. So f of x is not equal to f of negative x. Okay. Now we need to check negative f of x and compare it to f of negative x. So negative f of x means all I have to do is change the sign, so that's negative x cubed plus 3x squared plus x minus 3. Okay, f of negative x, comparing it to this, they are not equal. So f of negative x is not equal to negative f of x. So it is neither. It is not an odd function, and it's not an even function. That is it for this lesson. Thank you. Bye.